Hello everyone, Sean Mancini here. So first of all, I'd like to start off by saying I am sorry that I haven't been around my channel lately. I've been working on a ton of different projects and stuff like that, and I haven't really gotten time to make some videos, but I'm back. Um, so I'm back with a new set of videos that I'm going to be putting out, and I want to do a mini computer science course, and it's going to be based on the Python programming language. Python is my favorite programming language, aside from C. I'm better at Python than I am at C, though. And that's because Python I use more often than C. Python is used for things like web front ends, text manipulation. It's an interpreted language. So before I'll just say the tidbit. So like for instance, an interpreted language is a language that pretty much the file remains in text format. It is not converted into machine language until it is run. So when it's run, there's an interpreter, like an intermediate piece of software that takes the lines of code and then processes them all the way down and converts them to machine language when needed. Versus a compiled program where that's already done. But before getting into actual coding and programming and all this stuff, one thing I learned long ago is that yes, learning how to program and write code is one thing, but you should also know exactly what's going on. When you do a loop in a program, what is a loop, right? And I found that long ago I was able to create programs, but I could never really understand what was going on at the lowest level of the computer, and until I actually sat down and said, you know what, I'm going to learn how this ubiquitous machine that I'm on all the time works. And I learned that a long time ago, and the one thing is that it hasn't really changed. It hasn't changed much. So, let's talk about the very first thing. When you go and type in something like, hello, my name is Sean. So I guess I'll call, first of all, let's do this. Let's call the first video in this track binary, Ascii to binary. And I'll tell you why it's important to know that. So we type in, hello, my name is Sean in the computer. Some people automatically assume that the computer knows what this means. It doesn't. The computer does not know what letters are. Your CPU, motherboard, RAM has no clue what this is. So the way that the computer knows is by ones and zeros. So let's rewind the clock long ago when computers were very mechanical. So in order to accomplish a task, certain circuits and everything were turned on and certain of them were turned off to accomplish a task. So 1 plus 1, we turn on certain circuits, turn certain circuits off, and then eventually vacuum tubes came out, and then the advent of the microprocessor. So now with the microprocessor, it's the same thing, but we have transistors, and we turn hundreds of these transistors on and off to accomplish a certain task. And so in order to do that, we still use the binary system. So what is the binary system? So the binary system is the ones and zeros. So binary. Binary is ones and zeros. Okay. Now, with the binary system, we learned long ago that we can theoretically it's possible. Okay, so let's just go to this terminal instead of the Python window. So theoretically, it's possible. Let me write back my notes here. Okay. Theoretically, it's possible to sit here all day and write an app like this. But I think me and you can agree that that would be horrible. That would not be fun. So what computer scientists of the day created was a system called Ascii, the American Standard Code for Information Inter-Exchange, Ascii. And what this did was change the input of a letter, so say A, and converted that to a binary number. Okay, and how it did this was it put a decimal character, or decimal number to each of the characters. So, for instance, A has a decimal number of 65, which ultimately reads to 01000001. So, when you type in A, like I did right now, okay, my keyboard went to the keyboard buffer, which then went to my operating system, which accepted an input of A, in reality, that A, even though it is showing up as a character on my screen of A, it's really 01000001. That's what my CPU recognized when I punched in that key. It just happens so fast that you don't even realize. So that is one of the fundamentals about when you type in something into your keyboard, that your computer had no idea what that letter was. Now, let's take an example here. Okay, so this is an image which I will post in the video section, or so the comment section. But let's see the layers of programming and the layers of input and all that stuff. So at the very lowest level, you have your hardware. This is your hard drive, your CPU, your motherboard, your RAM, all that stuff. On top of that, machine language, which is 10100011, the binary system. On top of that is the assembly language. So this is the language that converts all of these higher level languages down to ones and zeros, ones and zeros. Above the assembly language, we have the high level language. Okay, so the high level language is your input from your keyboard and all that stuff. And above that is when we see our programming languages, such as Fortran, C, and Pascal. Now, those are very old. Those are very old programming languages. Except, even C is pretty old. So Fortran was a computer programming language of the 70s. It stood for Formula Translation or Transaction, something like that. I believe it was Formula Translation, I believe. C, okay, was created by Dennis Ritchie. And Pascal was another programming language of the day. Then on top of that, you have your visual languages, the drag and drops and all that stuff. The highest level, which your drag and drop, your HTML, all that stuff. So stuff like that is not even a programming language. It's more of like describing what something looks like. That's what HTML is. Is more of describing how you want a page to look. It's instead of creating a function or creating a method for that to happen. So this is the pyramid of, once you type something in, and all the way down, it goes through all of these layers, all the way to a hardware level. So when you create an application in Python, you're right here. Okay, so you're right around here. Okay. And then it goes from there to assembly language, to machine language, to hardware. So that's an interpreted language, for instance. So when an interpreted language, when you go ahead and run a code or run your app, it starts from here, goes down to assembly, goes down to machine language to be executed by the hardware, and back up. Now, in a compiled language, you pretty much start from here. It's already compiled, already ready for already ready to interact directly with machine language that eventually goes down to hardware. So this is a very important concept to learn. And what we'll do is we'll start with talking about how some of these layers interact and all that. I'm going to skip exactly how hardware works, but we'll touch on it in my next video about how some things work. I may actually skip that and go, and we'll start doing coding, and in the meanwhile I'll give you some readings if you want on the beginnings of hardware, like Mary Hooper and all of the historical view of hardware and how hardware came to a computer that took up an entire room to a laptop or a tablet. So that's the very first thing, learning about the layers of programming, the levels of programming languages, and the binary versus Ascii system. If you have any questions, you can always email me, Sean@SeanMancini.com. You can visit my website, www.seanmancini.com. I hope this was informative for you. And if you have any suggestions, please leave them in the comment section below. Thanks, guys. Bye.